Okay, can you see this? All right,
Yes, sir.
very well.
Yes.
Okay, so basically we have okay, we already discussed about these topics, motion in one dimension, but not all. We only discuss about motion when it deals with the positive x or positive and negative x directions only. Okay, so let's look at what we have learned. Okay, we learned about displacement. Okay, displacement. Okay, displacement, velocities, accelerations, and one-dimensional motion with the constant acceleration. Okay, what I want to highlight today is the equations of this. Okay, yes, I want to highlight in terms of this kind of equation. V equals to V naught plus AT. This one can be comparable to the one that you or learn in your school days, which is V equals to U plus AT. Okay, so look at how they represent U. So right now we will, you must use this kind of equation V naught. Okay, where the naught is actually initial velocity, final velocity. Okay, final V. This one is initial initial velocity. So the difference between just a knot there. Okay, a knot. Okay, so A is acceleration and time. And then I would like to highlight on this equation, delta x. This equation. So normally this equation is based on your understanding in terms of motion. Okay, during your school days, it will be written as S equals to UT plus half AT squared. So that is the equations that you learn in your school days. But S stands for displacement. And okay, in the displacement, okay, sasaran, okay, so this is the value. Okay, but displacement in our terms right now, okay, because this, where we look further, the displacement is actually based on the final position minus initial position. So therefore, this one is the delta x, which is change in x, change in position. So that's why we have okay, do some modifications to the actually we don't do a modification, we just replace s with the delta x. So the delta x now stands for change in positions. Okay, so basically change in position equals to initial velocity times time plus half at squared. Okay, so that's with the this equation. Okay, normally you just use this equation, v square equals to u square plus 2as. So this s you change to delta x. But this all equation, all of this equation is based on the our understanding that all motions move in x direction. Okay, all motion move in that x direction. Either it's positive or negative, doesn't matter. But it's all moving left to right, left to right, left to right. Okay, what does it mean by left to right? Is that if you do have a Cartesian coordinate like this, all of the, let's say this is your object. So all the object move to the right or move to the left. Okay, this is what we mean by move left to right, left to right. Cool. So this means this one is going to the right is called positive x, and going to the left is negative x. Okay. So there are three different or three very important equations here, which is v equals to v naught plus at, delta x equals to v naught t plus half at squared, and also the last one, v square equals to v naught square plus 2a delta x. Okay, now we will look further in terms of the examples of it. I think all of you have already go through these examples one by one. Okay, hopefully you can understand these concepts. Okay, if you want to apply that particular equations, for example, okay, we have v equals to v naught plus AT, or delta x equals to V naught T plus half AT squared, or maybe you want to apply V square equals to V naught square plus 2A delta x, 2A delta x. So that is how you want to, based on what? Based on the constant acceleration. This is
Acceleration.
constant acceleration.
Acceleration.
Can you mute the mic, please? Okay. So what is the velocities of the car after it has traveled? 100 feet. Okay. So how much time has elapsed? So you can try on your own, right? Okay. So this is also a good example for you to understand the concepts of position as a function of time. This is the position as a function of time. Okay. This is the good example where this one is the just an x of the car against x of the trooper. Okay, you can try on your own this one. Okay, so now please concentrate on that three particular equations, because that particular equations we will try to expand in terms of the usage of that particular equation. This equation, for example, velocity as a function of time. Okay, position as a function of time, or the displacement as a function of time, and also the velocity as a function of displacement. Okay, so we want to expand the usage of this equation in terms of other motions. For example, now we will have a new motions, okay, of free fallings. Free falling objects is something that falls under the influence of gravity, under the influence of gravity, meaning that if you have some heights, okay, if you tend to stand at some a building, a very tall building, okay, you're holding some stone here and you release the stone. Okay, you release the stone and the stone will go straight downward. Okay, straight downward or straight upward. Okay, that then it give the gravity to influence your motion. So the gravity will take place, all every considerations of accelerations inside your motion. Right now, everything will take place. So when you have a equation of V equals to V naught plus AT, okay, so right now the A will be something else. Why? Because we have A at the gravity. Before this, okay, the motions only involve in x directions, whether it's going to the positive x or negative x, doesn't matter. Okay, but this one we need to calculate or acceleration have already been given to you. Okay, but in terms of free falling, okay, the accelerations of that object or the motions of the object will depends, okay, mostly on the gravity, meaning that you know that the gravity is actually the full name of the gravity is the gravitational acceleration. Gravitational acceleration, that means gravity is an acceleration, but in y. Okay, if you look carefully, this motion move either upward, straight upward, or downwards, atas atau ke bawah. Dia tak bergerak kiri kanan. That means we need to assume that this stone will move straight downward, straight ke bawah saja. Maknanya dia tak adalah kata dia pergi ke sini ke, dia pergi ke tepi ni ke. No. It's just straight downward, straight down. Very, very rare case if you want to consider this, because due to the wind resistance or whatsoever, we will still have some distortions of motions here. So we can see that maybe we cannot have, when we try to throw the stones, okay, or when we try to release the stones on top of the tall building, maybe the stones will occasionally move away from the original positions of what it should land on the ground. Okay, so this is the one that the physics need to assume. That's why the word assume. Okay, menganggap, assume. Okay, physics need a lot of assuming. We need to assume that the stones falls have a free fall motion. The free fall motion stands for either is going straight upward or downward, but with the influence of the gravity. The influence of gravity. That means you didn't throw it. Uh, you just release the stone. Release the stone. Or maybe you want to, throw the stones. Okay, throw the stones upwards, and the stones. Okay, the question must tell you that the stone is going straight upward, and then and reach the maximum level, and it will go down, straight downward. Okay, straight downward. Everything must be straight downward or straight upward. You cannot have a situation where the stones moving away from the original positions, which is here. Okay, so it's either at B or either at A. Now it is not under free falling motions. So in the free falling motions, the G, the gravity will be, we will use the gravity's value at 9.8 meter per second square, and it is not 10. Okay, please make sure that you have passed your history in terms of what you learned in the secondary school. Use 9.8 meter per second square instead of 10, because this is the gravity values that we will use at the university level. 9.8 meter per second square. Sometimes we have 9.81, depends on the book that we are used. But in the survey textbook, we will use 9.8 meter per second square. Okay, so an object falling in the air is subject to the air resistance or wind resistance. Okay, so air resistance udara, and therefore it's not free falling. If we try to if you do have one ball and one piece of papers, and you try to make it a free fall under the subject to the air resistance, so definitely this ball will fall first. Okay, we reach the ground first compared to piece of papers, right? But when you have a ball, okay, and then you crumple the papers, okay, so that means the surface area of the paper have been changed to the ball like, okay, dalam bentuk yang macam bola, so it reach almost at the same time. Okay, then however, what happens when we did it in the vacuum? For example, if we did it in the vacuum, what happened to these both? So definitely ball and papers will fall at the same time. Okay, will reach the ground at the same time because there is no resistance in the vacuum. So every possible object that have mass must fall or must reach the ground at the same time. Okay, all right, so that is good analogy. All right, so this is the examples of what you should expect in the. So let's look at this example. It's a very good example when you want to understand the concepts of free falling. Okay, a ball is thrown from the top of a building. Okay, this is what happened when the ball is thrown. Okay, so before you reach to this part of the equation, you must make sure that you have already obtained or you have already mastering, okay, this equation. V equals to V naught plus AT. Always, okay, always you need to memorize, always you need to be able to write down everywhere. Okay, these three equations together. Okay, V equals to V naught plus AT, V square equals to V naught square plus 2A delta X, and of course, delta X equals to V naught T plus half AT square. You must always be able to write down these things. Okay, or regardless of maybe you have equations in front of you, that's it. Okay, when you do or when you try to solve the problems of motions, always make sure that this equation always must come together. Okay, you cannot just memorize one and just leave it for the other two. No, You need to memorize all equations involving motions, especially these three. Because when we want to learn motion in 2 dimension afterwards, then we need to apply these equations. Okay, so right now, the equation now is thrown from the top of a building. Okay, look at the question. With an initial velocity, this one taken out to be V naught. Okay, look at how they write down straight upward. Is very impossible for us. In reality, it's very impossible when we want to have a straight upward of throwing things. Okay, because we may still have an angle. The ball or the stone that we throw must always have angles. Okay, it's very rare case. Okay, the free falling is very hard to get in terms of straight outward or straight downwards. Okay, so an initial height of 50 meters. 50 meters, why? Because due to the tall of the building plus with the height of this man. Okay, 50 meters above the ground. Okay, so basically this is your ground level. Right. The ball just misses the edge of the roof, meaning that this is the edge of the roof. Okay, ketinggian bangunan on its way down, meaning that this man throw the balls straight upward and then the balls reach the maximum height. This is where the ball should reach the maximum height. This is maximum height. Okay, you know what happens at the maximum height? The velocity is zero at that time, meaning that the velocity, the ball cannot go up anymore. Okay, that is the maximum velocity, and then at that particular time, V naught or V naught, I'm not sure, V final velocity at that point is zero. Okay, so and then it will fall down under the influence of free falling, because right now when it goes straight downwards, okay, when we can assume when it goes straight upward, it also goes straight downwards. Okay, straight downwards, and then we can apply the free falling methods. Okay, so the ball just misses. Determine the time needed. Okay, the time needed. Okay, the time is always associated with something related to motion. Okay, when we talk about motions, you need to know which time happens, which height happens at the particular time. So that is the very important things. When you try to solve the problems of motions, you need to know the exact time, the exact seconds. What happens at this time? What happens to the seconds? So the time needed for the ball to reach its maximum height, right? So the time needed for the ball to reach its maximum height. So what happened? So you need to apply V naught, V equals to V naught plus AT. So V will be zero. Why V 0? Because this is the maximum height. Okay, so look at how they apply the equations, and then you want to find the time. First of all, you need to know the time. Okay, if you write down this equation of V square equals to V naught square plus 2A delta X, it is not impossible. It is not possible because there are no time inside the equations. Okay, so we need to use the first equation, V equals to V naught plus AT. So the initial velocity is 20. Okay, at least everything here must be discussed in terms of its SI unit. Okay, so 20 is the meter per second, and A here, look at how they write down. This is the original equations, but right now A is equivalent to negative G. Why A equals to negative G? Because acceleration, okay, to be on the safe side, everything that move out from the ground, okay, every body or everything that have masses that leave the ground, okay, terapung ke atas udara, then we will apply this method. A equals to negative G. A is always equals to negative G. You know the value of G? G is always 9.8. But when you write down A, it will be negative 9.8. So that's why when you put inside this equation, now it becomes negative. Okay, so Remember, when you have object, or you have masses, the object that have masses, okay, when it leave the ground, so you need to apply A equals to negative G without any doubt. Okay, with any doubts, you need to apply A equals to negative G. You know G, 9.8, but A is negative 9.8. It's the same thing. Don't get it confused because G is always 9.8. Gravity, when people ask you, what is the gravity value? 9.8. What is the acceleration? Okay, acceleration based on our terms. Okay, remember, this is very important for you to understand. Okay, acceleration now, we move in a free falling. The free falling will discuss a lot in terms of y-axis. So y-axis is like this. So this is the 0 at y-axis. This is the positive A, and this at this point will be negative A. Okay, so anytime you want to apply the gravity, okay, always remember, if you are applying this equation, V equals to V naught plus AT, remember to replace it with the negative G, or else you just put A equals to negative 9.8. Is it all become negative 9.8? Yes, when the object move in the air, or when the object, okay, leave the ground. Objek duduk terapung saja, kita pakai A equals to negative 9.8. Gravity berapa? 9.8. Gravity is always 9.8. Okay, itu saja, kena faham, right? Okay, for the ball to reach its maximum height, then you calculated, okay, take out your calculator right now. So you calculate on your own that T is equivalent to 2.04 seconds. So it needs about 2.04 seconds to reach its maximum height. Okay, now look at number B, the maximum height. The maximum height means they want to find the displacement. Or you want to find the distance, jarak dia. Berapa maximum height dia. Then you need to apply this kind of equation. Look carefully. What is this equation actually? So basically, when you are dealing with the motions in one dimensions, okay, you need to separate between motion in X and motion in Y. Okay, for example, these equations, this equation, delta X equals to V naught T plus half AT squared. This one is for X axis. What happens to the Y axis? Now you can write down as AY equals to V naught T plus half AT squared. Why? Because at X now, this is the change of X final minus X initial. And eta Y means Y final minus Y initial. Simple. Okay, so in this case, okay, this is all about something that going up and down, atas ke bawah saja. So atas ke bawah tidak ada melibatkan x-axis. So we need to apply y-axis. So this is actually the same equation as this. Okay, but the y final, so dia ambil yang y initial ni dibawa ke sebelah sana. Okay, so therefore it becomes like biasa dia macam ni, delta y equals to V naught T plus half AT squared. But right now, Y dengan delta minus the Y naught, so Y naught dia bawa ke sebelah sana. So that's why it becomes like this. Okay, so don't get confused. So Y naught means that the original position to happen to be dekat sini. Original dia, this is considered to be Y naught. Ujung ini considered to be Y. Maksud dia final position dia. Okay, but in this case, based on time yang kita akan gunakan, which is 2.4, 2.04 is the time where it reach the maximum point. Reach the maximum point. Okay, so this is not the time where it touch the ground. No, this is the time where it reach the maximum point. So this Y is actually here. Sebab tu kita kena tahu, walaupun nama dia final position, tapi which final. Kalau kita gunakan time 2.04 merujuk kepada final dia di maximum point ini. Okay, and then you calculated, you get 20.4 meters. All right. Okay, and number C, the time needed for the ball to return to the height from which it was thrown, which is here, dekat Y naught ni. So dia nak tahu dekat situ berapa dia dapat. Berapa timing dia. So you can use this equation, okay, ataupun maybe you want to use the equation from first, sebab ingat kalau dia baling straight outwards, okay, dia baling dekat sini 2.04 seconds. So dia jatuh belah sini pun 2.04. 2.04 plus another 2.04 dapat 4.08. That is one. Dan ataupun guna equation ni, okay, nampak dia dapatkan time. So dekat sini ada quadratic function kena dapatkan. So dia dapat 4.08 second. It's up to you. You can use it. Okay. And then at part C, okay, ada dua soalan dekat situ. The time needed and also the velocity of the ball at that instant. So the velocity, now you use this equation, 20 for the initial velocity, 9.8 as the acceleration, and time 4.08. Now look at how they write down the answers. The final velocity at this equation, at this point, okay, at this point will be negative 20 meter per second. Look at how they write down the answers with the negative. That means the velocity now is negative. Why? Because it's going down. It's against the original velocity. The original velocity is going up, but right now it's going down. So we know from the final velocities taken from your calculations here, we know that the ball is falling down under. The ball is falling under the same height as it was thrown. So that's why we need to understand the concepts. Okay. Okay, so that's why you go to the D, the time needed for the ball to reach the ground. This is very good. Okay, look at how they use the equations. Y equals to Y naught. Don't get it confused because this is delta. Delta Y equals to V naught T plus half AT squared. A is negative G, which is the negative, already negative here. Okay, look at how they simplify. The Y is the initial, the Y is the final position. Y naught is 0. Okay, in this case, okay, dia ambil dekat sini sebagai 0. Ada setengah orang nanti, dia buat ikut selamasa dia. Maksud dia, dekat sini dia buat 50 meter, dekat bawah ni 0. So, dia kena ubah dekat sini lah. Okay, so is it the same thing? Okay, but you need to know the exact locations. Betul, yang mana satu kamu anggap Y, yang mana satu kamu anggap Y naught. Where is your Y, where is your Y naught? So you need to establish words. You need to write down, this is our Y, this is our Y naught. For these examples, this is the Y naught. Ni Y naught dia, dekat sini Y dia. Macam saya cakap, dalam equation ni ada dua Y. Satu Y dekat sini, which is the final position after the stone. Okay, reach the ground. Lagi satu Y dekat sini, which is Y bila the maximum height. Macam mana nak tahu beza dia? Kita tengok pada timing. Timing 2.04 dia reach the maximum height. Timing 4.08 dia baru sampai sini. Timing yang baru which is D, ni kita nak calculate ni, dapatlah 5.83. So it took about 5.83 seconds for the ball, okay, after it reached the hands of the thrower tu, okay, orang yang baling tu, dan jatuh 5.83 seconds after it was thrown. Okay, so look at part E, the velocity and the position of the ball at time t equals to 5 seconds. So this is some questions. Just want to test you in terms of your understandings. Where is the velocity and position at that particular time? Okay, so at time t. So definitely 5 seconds. The ball reached the ground at 5.83 seconds. So at 5 seconds, definitely somewhere around here. So the ball didn't touch the ground yet. Okay, so in this case, so they calculated V0 initial velocity plus with the A here, remember negative 9.8. 8 times t, 5 seconds. So you will get negative 29 meter per second. Look, they write every units. Okay, every units must be write down correctly. And then at the end, the positions, okay, they use the same equation, y equals to y naught plus v naught t plus half at squared, 20 initial velocity time t, half 9.8, and then they will get negative 22.5 meters. Okay, is there any questions? Okay, so let me share another slides of two-dimensional kinematics. Okay, now we have to learn a little bit of two-dimensional kinematics. Okay, can you see the slide?
Yes.
Yes, sir.
Okay, thank you. Okay, so that is right now we want to discuss more in terms of two-dimensional kinematics. Okay, so this is two-dimensional kinematics. Okay, I would like to highlight first. Before this, we learn separately. Okay, motion in one dimension is either x-axis or the free falling. Free falling is only y. That means x and y didn't come together at one questions. Okay, so x and y separately. We calculate separately x motion in x and also motion in y. Okay, so what happens when we try to deal with the two-dimensional kinematics? This is the kind of two-dimensional kinematics. So, for the example of Angry Birds game. Okay, the Angry Birds games is not just a normal game. For your information, the Angry Birds games have now associated with the NASA. Okay, sometimes they have been associated with the NASA. The NASA use this game to create awareness. Okay, for the students, for the children, for example, to understand the concepts of physics in a better way. Okay, to introduce physics to the community. Okay, so this is the concept where you want to this bird want to hit the peak, the green peak over here, but you need to do some damage. You need to calculate. You need to know the right angle, the correct. This is the correct velocities. Okay, maybe you want to pull the strings at a very maximum level or what. So in order for you to hit this green peak, so this is the kind where you want to apply, okay, the concepts of two-dimensional kinematics. Okay, so what is two-dimensional kinematics? It's based on the motions, okay, based on the motion that comes together. X and Y comes together. Okay, now we need to see this. Okay, motion in two dimensions. Yes, I want to highlight this. When we talk about motion in two dimension, each equation is so hopefully, okay, hopefully you have already established, you have already familiar with the equations of, for example, V equals to V naught plus AT. Okay, V square equals to V naught square plus 2A delta X. Okay, this one. Okay, or last one will be delta X equals to V naught T plus half AT squared. But this only happens before this from each direction. Maybe it's either X or maybe it's either Y. Either X or Y. Okay, but it's not in the same case. When we talk about X, it's just an X. When we talk about Y, it's just a free fall. But right now, in two-dimensional motion, two-dimensional kinematics, everything have to be double. Okay, for example, position as a function of time, you can write down every value. Okay, look at all the equations. This is the equations. This is based on equation of delta x equals to v naught t plus half at squared. This one is the v equals to v naught plus at. This one is v square equals to v naught square plus 2a delta x. Of course, I always use delta x, but in fact, you need to know that there are two. Actually, there are two, which is delta y and delta x. Okay, right now, every equation, either is function of time or position as a function of time, or velocity as a function of time, or maybe velocity as a function of position. You must come with the two axes, which is x and y. Okay, to exist. Look at how they write down. Okay, when in x direction, this is x, this is all x, and at the bottom is all y. Look at how they write down. Everything have to be added with x. Okay, for example, x is always x. Okay, we don't have, you need to put another x here. So basically, the delta x is actually, okay, delta x is x minus x naught. So this x naught, it brings up here. Okay, so now it becomes x equals to x naught plus v naught. Asal dia v naught. So we now need to add x, v naught x, t. Time doesn't involve in the concepts of x and y direction. Okay, that time doesn't influence. Time is independent. Okay. Plus half. A, what happened to A? A is a x and times with t squared. And look at y. So y is delta y equals to y minus y naught. So y naught it bring up here. Y naught plus v naught y t plus half ay t squared. Okay, how about this one? Now, vx equals to v naught x. Now, it added x, it added y, x, it added y, ax, ay. So you must do this every time you see these three equations. Okay, you must expand it in terms of x and in terms of y. So this one also, vx square. Now added x, added v naught x, delta x. This one is already x. Y, v naught y, y, and delta y. So this is how you expand the equations of these three. From 3 now it becomes 6. According to the axis. So what happened next? All of the equation now, it should be written in the concepts of this one. Okay, when you try to eliminate, okay, this one is not 9.81. G is 9.8 meter per second square. Okay. So basically, when we have these three equations, what have these 6 equations? Now, please remember the projectile. Okay, the projectile. So please always familiar with this equation. This word projectile means motion in 2 dimension. Motion in 2 dimension. That means it moves together. X moving, Y also moving. So what is the conditions of X and Y? What is the conditions of projectile? Okay, the conditions of projectile motion is Ax will always equals to 0 and Ay will always equals to negative G. Ay equals to negative G and Ax will always equals to 0. This is the projectiles terms and condition. The condition, it must follow ax equals to 0, ay equals to negative g. So what happens to this kind of equation? Right now, if you look carefully, this equation, if they have ax, then it become 0. This one become 0. This one become 0. Whatever to the bottom part, it becomes negative, negative, negative. Okay, everything become negative. So that's why from these equations, okay, from this equation, we can get these types of equations. Yes. This is from the x equals to x naught plus v naught xt plus half at squared ax. So this one become 0. So that's why all left here is x naught plus v naught xt. Okay. So this one vx from the v naught x minus plus with axt. So ax 0. Okay. Look at this example. Ax 0. So this one becomes 0. So all left here is vx equals to v naught x. So that with this thing, vx square equals to v naught x square plus 2ax delta x. But everything here will be 0. So all left here in vx equals to v naught x square. So this is the equations that have been modified due to the conditions of projectile. This one. Because this is how now they get the projectile equations. So remember, from 3 equations, from the equations of motion, now you have 6 equations. Okay, they've been expanded, but you need to know something. Okay, you just need some understanding, which is ax equals to 0, ay equals to negative g, and then you need to add every possible subscript of x and y, and then do eliminations, do your own eliminations. So first, you need to remember, you need to know how to use these 3 equations. Remember, okay? First, tahu dulu guna 3 equation yang asal tu. Lepas tu, expandkan dia kepada 6, which is letakkan dia punya value-value. Lepas tu, kamu eliminate yang ax equals to 0, ay equals to negative g. And then you will get this 6 equation. Number 1, number 2, number 3, number 4, number 5, and number 6. Normally, when we do the problems, we only use number 1, kebiasaannya lah. Okay, based on my experience, we will use a lot of number 1, equation number 1, equation number 4, okay, equation number 5, and some things maybe equation. But 1, 4, 5 is the most equation that we use in the projectile motion. So we will use a lot equation number 1, number 4, and number 5. Compared to number 2, number 3, and number 6. But you cannot eliminate, or you cannot okay lah, tinggal je lah. No. Okay, at least you must know. Okay. So another types of projectiles is, okay, this is the general launch angle for the projectile. Okay, so projectile, for example, is the one that we have here. For example, this is the golf. Okay, the golf. So the golf have been hit with the certain angle. That's how you know the difference between motion in one dimension and motion with projectile. Projectile means both axes involved, x and y. If you look carefully, when it involves the angles, so that means 90% it must involve with the projectile. 90%, 99%. I could say 99% of our calculation must based on the projectile when it involves angle. Okay, so this angle, for example, this is the v naught, the initial velocity. So the initial velocity must come together, because this is vector, it must come together with the v naught x and also v naught y. So how can we derive v naught x? So v naught x is easy. based on our learning lesson in terms of vector, V naught x is V naught cos 54, and V naught y. V naught y is V naught sines 54. Okay. So the idea of projectile is actually based on this part. Yes. This is V naught. This is V naught x. This is V naught y. So V naught y is V naught. The theta is always here. Okay. So when the ball have been lifted up, okay, to the air, now it doesn't have V naught anymore. Now it will have V. So this is V, and this is Vx. But remember, from our understanding of Vx is equals to V naught x. Okay, Vx is always equals to V naught x. So that's for they only write down here as V naught x. Look carefully. This is V naught x. This is V naught x, and this also V naught x. Why? Because the component of initial velocity in x direction, the component of x velocity in x direction will always have the same value. Will always have the same value. But the difference is when you look at the component of initial velocity or component of velocity at y-axis. Okay, look at y. So first of all is V naught y, and then it becomes Vy, slightly shorter. Now here Vy at the maximum point, Vy will be 0. Okay, what happened here? When the ball is starting to go down, then Vy will be negative. And what happened next is V naught y here, it will be negative when it reaches the ground. So that is the difference between Vy and Vx. Vx is the same value throughout the system or throughout the calculations, but when you calculated Vy, then you need to calculate it with the proper timing. You need to know which time here, which time here, which time that Vy here, for example. So every time will give you different Vy or initial in or velocity in the y directions. So that is the difference between motion in one dimension and two dimension. You need to know. You need to know the difference. You need to know which part that you are using now. Maybe you are using y, maybe you are using x. So you need to know the difference between x and y. And of course, in motion in two dimension or projectile, everything comes together. X and y comes together. It doesn't separate. Like the one that we did in our last lessons, which we learned x, which is x kiri kanan, dia gerak kiri kanan je, ataupun free fall, dia gerak atas bawah je. So in here, it move like a projectile. It move like a something like parabolic, some kind of parabolic. This is the parabolic path. Okay, every time they have a parabolic path. So this is the reality. When you are throwing something, it's very, very rare and very hard to get the straight downward or straight upward. Okay, but you throw things, it must come with the angle. So therefore, projectile is the reality of the motions, reality of the motions. And you're throwing some things, it must involve why projectile comes in our life, because of the resistance from the air resistance. So that's why we get projectile. Okay. So why we learn projectile? Because we need to calculate in terms of x-axis and y-axis together. So by using of the equations from this, okay, you establish the 6 equation that you remember. Ay equals to negative g and ax equals to 0, where v naught x is the v naught cos theta and v naught y is v naught sine theta. Okay, all right. So there are a lot of equations. Okay, I would like you to try all the equations or all the examples and we can try it during our next class. Okay, so I think I'll stop here because that should be the time, 10 o'clock, before you come to the class. Okay, okay, so I think that will be the end of the class.
Sir, how about attendance?
I already took it. I already took the attendance.
Alright, sir.
Okay, because it's automatically into my mid attendance collector. Okay. Okay.
Okay, sir.
Thank you, sir.
All right. So